All right, we'll take a look here at section 3.1 as we look at defining the complex numbers. So we've been talking about real numbers, but we now want to introduce complex numbers as we get into the topic of solving quadratic equations in this chapter. And with quadratic equations, you have the possibility of complex number solutions. Now, complex numbers are numbers formed by adding multiples of what we call our imaginary number in math, I. So I, right, is your imaginary number. So I is defined in math as the square root of -1. So we think about a negative and a square root, right? We're undefined in the real number system. But this is where we get into the complex number system. So I equals the square root of -1, which implies if you were to square both sides, right? What is raising both sides, for example, to a power of 2? As long as we do the same thing on both sides, this is the principle of powers, right? It's still equal, and we simplify down to I squared equal to -1. And that's probably the most important thing that we want to be able to remember from this section to help us in simplifying complex numbers. All right, so we're going to talk about I squared as we work through this section. So if we square I, we get a real number back. We get the integer value of -1. All right, so again, with that said, a complex number, again, is a number formed by adding real numbers and multiples of I. So I want to talk about the standard form. So standard form of a complex number is a number of the form A plus B times I, where A and B are real number coefficients. A and B are the real numbers from this complex number. A we refer to as the real part of the complex number, that constant term added to your imaginary term, your I term. And B, the real number coefficient of I, will be the imaginary part. So we have two parts to a complex number, the real part and the imaginary part. So again, adding multiples of I, right? We're forming a complex number. So let's take a look at some examples here. It says here to simplify, write your answers in the form of A plus BI, where A and B are real numbers. So let's start off with, we'll look at adding two complex numbers. So you can see in this example, we've got two numbers in standard form. They're complex numbers, are both of the form A, right, plus B times I. So we've got our standard form complex numbers. So we want to add these together. So to add this straightforward operation, we're going to combine the like terms, right, of both numbers, the real parts from both. So as we do that, we get what? -6 plus 9, which is 3. And then we have a -5i and a 2i. All right, as they add up together, we get a sum of -3i. So we end up with a sum of 3 minus 3i. So there's our standard form, right? Complex number where our real part, A, right, is 3, and our imaginary part, B, would be -3. So there's A and B. So there's the sum of two complex numbers. Again, adding, the like parts together, the real parts and the imaginary parts together with these. So let's go ahead and look at another operation. Let's take care of the difference of two complex numbers. So we've subtracted. We've added. Let's go ahead and subtract. So here you can see we're finding the difference of -3 minus 4i minus 8 minus I. And be careful when you're subtracting a complex number, and like this one, we have two parts to it. So that's probably the most common mistake made, is forgetting to distribute that minus sign to both parts. So -3 minus 4i minus 8 minus a -I becomes a plus I as we distribute. And then we can combine our like terms. So we have the -4i and I, which is -3i. And we have the -3 and the -8, right, which add up to, what, -11. So in the end, we end up with a standard form complex number of -11 minus 3i. right? So our standard form complex number. All right, now we've done addition, subtraction. Let's go ahead and multiply two complex numbers. So here I've got two numbers in standard form, complex numbers, 1 minus 2i, a is 1, b is negative 2. Multiply with 1 plus 3i, again, standard form complex number, a is 1 and b is 3. As we multiply, as we do the product, right, we're going to go ahead and distribute. So let's go ahead and take the 1 and distribute it through. So 1 times 1 is 1. 1 times 3i is 3i. And now let's go ahead and distribute the negative 2i through. Negative 2i times 1 is negative 2i. Negative 2i times 3i is a minus 6i squared. Right? Now remember what we just talked about earlier. We know what I squared reduces to. So again, I squared, remember all of this equals negative 1. So as we simplify, what do we have in the end? We've got 1. Now negative or 30i minus 2i, they add up to 1i. So I got 1 plus I minus 6 times negative 1. So replacing I squared what it equals. So we end up with 1 plus I plus 6. As we add the two constants to term, our like terms, we got a 7 plus I. All right? So there's our product of those two numbers. Now I do want to mention, while we have it, your calculator does have imaginary numbers. So you can work with imaginary numbers on your TI. So if you want, let's pull that up. Go to your TI. And just to show you where I is above your decimal key. You see it here in blue. So for example, that last problem, if you want to write it in, we could. We got 1 minus 2, second decimal key. There's 2i. And then multiplied with 1 plus 3i. Again, second key in a decimal. Right, and there it is. There's our result of 7 plus I. So again, that's something you look at on your calculator if you need to check your work. Your calculator will handle those imaginary numbers. I want to look at example D, and we're doing a product again, but I want you to notice these products are opposites. This is conjugates. So we have conjugates in this next example. I'm going to make a note here on the side. Again, conjugates, which means opposites. So with opposites, we have a nice property involved. We end up eliminating our imaginary number altogether. Complex conjugates will eliminate I. So I want to show that. Let's go ahead and multiply it out. Let's go ahead and distribute. So as we do that, as we go ahead and distribute, I got 5 times 5, which is 25. I got 5 times negative 9i, which is negative 45i. And then we can go ahead and distribute the 9i through. 9i times 5 is 45i. And 9i times negative 9i is negative 81i squared. And there's I squared coming up again. We know what that reduces to, right? I squared is equal to negative 1. All right, now as we're simplifying, notice we have the I terms are opposites. They end up eliminating. So we end up simplifying down to 25 minus 81 times negative 1, which is 25 plus 81, which as we add together is 106. So in the end, we simplify down to a whole number. And that's our result, right, as we're working with complex conjugates, right? We're looking at, again, simplifying back to a real number. So we get this number here. Now there's a shortcut that we can introduce, and we'll put that here beneath it. I'll go ahead and write it down here with complex conjugates. We'll make this note. Complex conjugates. Here's a shortcut. A plus b times I multiplied with a minus bi will always simplify to the square of a plus the square of b. A squared plus b squared. So back at the beginning, for example, in this problem, right? A was 5 and B was 9. Well, 5 squared plus 9 squared, that's 25 plus 81. So right here you can see A squared plus B squared. That's your product with complex conjugates. So that's a shortcut that you could use to simplify. So we've added, we subtracted, we multiplied. Our last operation, let's divide. This is problem number 66. And let's go ahead and we'll rename it. We'll let this be example E. All right, so here in example E, all right, and then we'll do one more dividing, example F. All right, what we're looking at here is we're dividing by a complex number. Now our work, our goal, and we're dividing by complex numbers, is to eliminate I altogether from your denominator. Remember, my goal in the end is A plus BI. So I've got to eliminate I down here. So to do that, right, we want to eliminate I. We're going to multiply by the conjugate of the denominator. That's step one in working with a complex fraction. So what's the opposite of 2 plus I? 2 minus I. So we'll multiply the numerator and denominator. As long as we multiply by the same numerator and denominator, right, it's still equal. We're multiplying by a fraction of 1. It's the same number. We hadn't changed our number. And as we do that, notice what happens. So let's go ahead and do the multiplication. What is I times 2 minus I? I times 2 is 2I. I times negative I is negative I squared. Divided by, and let's go ahead and multiply in the denominator. So we can go ahead and distribute here. And you could, if you want to use a shortcut, it's going to be A squared plus B squared. It should be 2 squared plus 1 squared, which is 5. But we'll show that. We'll just go ahead and multiply it out. 2 times 2 is 4. 2 times negative I is negative 2I. And as we distribute the I through, we get I times 2, which is 2I. I times negative I is negative I squared. So, again, denominator and numerator, we can start to simplify. We see like terms. We see those I terms eliminating. We also notice that we have I squared, so we need to simplify. All right. Anytime you have a power of 2 or more on your imaginary number, it needs to be simplified. And we'll look at simplifying some higher powers of I in a little bit in some of our examples. But in the end, we've got what? 2I minus I squared minus negative 1 divided by 4 minus negative 1 as we substitute negative 1 in place of I squared since we've defined that from earlier. As we simplify, we get 2I plus 1, right? Minus minus makes a plus. And denominator, we get 4 plus 1. And there's that shortcut, A squared plus B squared. So end up with 2I plus 1 over 5. And you could, if you want, just to make it look a little bit better, I'll break it up so that you can see your real part and your imaginary part. So 1/5 plus 2/5 I. Right, there's your standard form complex number. So again, to eliminate I, that's our first goal. So again, that's step one, and I'll write that here in our notes so we won't forget. So step one, again, is multiplying the denominator by the conjugate. By opposite. And of course, you got to multiply numerator too. So again, it's a fraction. Got to do the same to the numerator and the denominator. So multiply denominator numerator by conjugate of denominator. That's your work when you're dealing with complex fractions. So denominator and numerator by the conjugate of denominator. Let's do this in an exact example here in example F. Now in example F, you'll notice we've got two complex fractions. Now one thing nice about these two complex fractions, we're trying to add, which means we have to have a common denominator, which we already have. So let's go ahead and combine these. So we can go ahead and add these together. So I have 3 plus 2i plus 6 plus 2i, all divided by 1 minus I. So again, we'll add up two fractions. And then we're ready to, of course, simplify. We can go ahead and simplify down the numerator. So we have what? 3 plus 6, which is 9. 2i plus 2i, which adds up to 4i. So 9 plus 4i, 1 minus I. And now I'm ready to eliminate I, right? So now we got to eliminate I from the denominator. So again, we got to multiply by the conjugate. So identify the conjugate. So 1 minus I, we're going to multiply by 1 plus I, right? The opposite. And let's do the product together. So what do we end up with as we multiply the numerators? Well, 9 times 1 is 9. 9 times I is 9i. And then we can distribute the 4i through. So we multiply 4i through. 4i times 1 is 4i. 4i times I is 4i squared. And again, we have I squared, so we know that we'll simplify. All right, that's going to be -1. And let's go ahead and do the same thing in the denominator. Let's go ahead and distribute. So we got 1 times 1, which is 1. 1 times I, which is I. And then we'll go ahead and distribute the -I through. -I times 1 is -I. -I times I is -I squared. And again, there's I squared that we need to simplify. We need to reduce down to -1. So in the end, I've got what? 9i and 4i. So we have a couple of I terms that we need to add up. So I have 9 plus 13i plus 4 times -1. All divided by, now in the denominator, things start simplifying nicely. Our goal was to eliminate I altogether, and we've done that in a step. And then, of course, 9 plus -4, as we add these together, right, we get a what? 5. So end up with 5 plus 13i divided by 1 minus -1, which is what? 1 plus 1, or 2. So 5 plus 13i over 2, and you want to separate it, that's 5 halves plus 13 halves I in simplest form. And again, you could put it in your calculator if you wanted to check it and simplify, you could. So again, those are working with complex numbers, right? Imaginary numbers, which again is something we're going to spend time with, right, in this chapter as we start to get into quadratics in our next section. All right, so we've gone through our 4 basic operations, right? Addition, subtraction, multiplication, division with complex numbers. Let's move on to our last part of this section, which is simplifying higher powers of I. And with that said, I'm going to use a couple of exponent properties. So I'll put some review properties in our notes. First property is a power to a power. You multiply the exponents, right? A to the x term, a to the x power, I should say, that exponential term, raised to a power y is the same thing as saying a to the x times y. So you multiply those exponents together. All right, well, another exponential property, if we multiply exponential terms together that have the same base, right, we can combine them together into one by adding the exponents, right? So again, we can add them together to combine them. So keep that in mind. We're going to use those in some of these examples. So let's take example A. Let's simplify this imaginary number. And again, I'm going to start off with a couple of even powers, and we'll look at what happens with odd powers. But I to 28 power needs to be reduced. We've got an exponent of 2 or more, it needs to be simplified. Well, I want to use what we've learned about I today. So remember, I squared equals -1. Well, let's use that. So I to 28th power, let's rewrite it with I squared. We know I squared to what power would be I to 28th power? Right? What do we multiply with 2? Right? Remember, a power to a power, you multiply the exponent. 2 times what is 28? Well, anytime we have an even power, we know it's divisible by 2. So we know 2 times 14 is 28. So yeah, I to 28th power, same thing as I squared to the 14th power. That's 2 times 14, which is 28. Which is equal to what? negative 1 to the 14th power because we know I squared is equal to negative 1. So we can plug that in. And negative 1 to any even power is a positive 1. Right? So again, if it's an odd power, it would be a negative 1. So again, we know rules of exponents. Even power on a negative base gets rid of the negative. 1 to any power is 1. So with that said, we've simplified I to the 28th power. So I to the 28th power is equal to 1. All right, let's do the same thing with example B. In example B, I've got I raised to the power of 10. I to the 10th power. Well, let's do the exact same thing. Let's rewrite it using I squared, what we know. So I squared raised to what power? 2 times what is 10? We know that 2 times 5 is 10. So this is equal to negative 1 to the 5th power because I squared equal negative 1. And negative 1 to any odd power remains a negative. So even power gets rid of the negative. Odd power, of course, remains a negative. So simplifying that down. So again, that's with even powers. It's going to always reduce to 1 or negative 1. Just depends on what you're raising I squared to. Even, it's going to be positive, negative. The odd's going to be a negative. Now let's take a look at example C. Now example C is a little different because now we have a odd power. I to the 19th power. Well, it's a little different. You cannot write I to the 19th power, rewrite it right now with I squared. 2 times 14 is, or I'm sure 2 times 9 is 18, 2 times 10 is 20. It's not an even number, so it's not divisible by 2. So it's not going to help me right now to rewrite as I squared because I can't get that whole number exponent. So what we're going to do with odd powers is we're going to factor out an I. So our first step is to bring out an I. As we factor out an I, we're left with 18 of them, right? I times I to the 18th, same as I to the 19th, right? Add the exponents, you get 19. Multiplying exponential terms, the same base. You add them. So with odd powers, you're going to factor out an I. Now as we do that, now we can reduce. See, now we can work on simplifying. Of course, I, which is square root of negative 1, that's already in simplest form. But this we can reduce down. So let's go ahead and do that together. So as we're writing that in here, we've got I times, let's go ahead and work on I to the 18th power. I'll keep it in brackets here. We know this is the same thing as saying I squared. We know 2 times 9 is 18. So again, with it being that even power, we can break it down with I squared. As we reduce, well, what do we end up with? We've got I times, as we go ahead and simplify, this is what? Negative 1 to the 9th power. I squared is negative 1. And we know that, right, any odd power on a negative base remains negative. So this ends up simplifying down to what? I times negative 1, right? So in the end, we've simplified down I to the 18th power. It simplifies to negative 1. Right, and we all know that negative 1 multiplied with I is equal to negative I. So again, with an odd power, you're going to remain imaginary number. It's not like the even powers where we simplify back to an integer value of negative 1 or 1. Well, with an odd power, you're going to remain imaginary number. You've got to factor out I and then reduce what's remaining. That even power will be left. So let's do another example, similar. Let's do the same thing with D. Let's go ahead and reduce I to the 9th power. Well, I to the 9th power is the same thing as saying I times I to the 8th. So factor out an I. And then we can reduce I to the 8th power, right? I to the 8th power is the same thing as saying I squared. 2 times 4 is 8. As we reduce that, what is I squared? I squared is negative 1. So we'll go ahead and write in there negative 1 and negative 1 to the 4th power. Again, the even power on negative 1 becomes a positive. So it ends up simplifying to 1, and 1 times I is positive I. So in the end, you get I. Now again, with odd powers, it's going to reduce to I or negative I. Just like even, it reduces to 1 or negative 1. All right, let's change it up just a little bit in our last one. And our last one, we've got a coefficient of I. We got 2I here, raised to an odd power of 5. Now, first thing I'm going to do is take care of this coefficient. Let's go ahead and take care of the power rule of exponents. We've got multiple factors in our base. That power distributes to each factor. So we got 2 to the 5th power times I to the 5th power. And we know that 2 to the 5th power is 32. And then we can work on reducing I to the 5th power. So that's I times I to the 4th, right? As we factor out an I to make it even. And that gives us 32 times I times, well, I squared, right, as we reduce I to the 4th power. And that gives us what? I times -1 squared. And with that, of course, that's 32 times I times 1, which just simplifies to 32I. All right, so that's simplifying higher powers of I and using our definition of I. Again, if I is the square root of -1, I squared equals -1. So using that to help us in simplifying. We'll continue to see imaginary numbers as we move on to our next section as we get into solving quadratics.